Well, hello everyone. How are you all doing? I'm sure you're all excited for this one. So, my name is Siddhant. I'll talk more about myself. Just give me a moment. But before I begin, allow me to take a moment and talk about the current COVID-19 pandemic, which has caused the extreme amount of panic and suffering to the entire world. The world is experiencing things it has never seen before. We have seen globally cities and countries going on a lockdown to contain the spread of COVID-19 pandemic. But we are all in this together. This too shall pass. Till then, just stay safe, stay healthy, and stay indoors. Uh, there's a long battle going out there. Things are not that great as we are expecting it to be. Things are really ugly. So just take a moment and step back. Stay at home. If it's not necessary, don't step out. So uh, we are all in this together again. But just stay safe and stay healthy. With this, let me welcome you once again for this session. My name is Siddhant, as you all know. Call me Sid. That's much preferred. I work as developer relations lead at Open Financial Technologies. It's a startup based out of Bangalore in India. Previously, I had worked as a program coordinator with developer relations team at Google in India. Talking a bit about what we do at Open Financials. So at Open, we are building something unique, a product called as Zitch.io, an embedded finance platform. So we firmly believe that financial services are a means to an end, not an end in themselves. It's only a matter of time before a majority of them will be delivered contextually within an existing product or service, driving better engagement, retention, monetization, or process improvement for the concerned product or service. That's my Twitter handle if you want to get connected. And a little more about myself. I've been in the industry for more than 6 years. Um, Found a passion in technology, community building. I've been in a lot of communities, startup building, startup ecosystem. Design thinking is another passion of mine. I do a lot of design spin sessions. Love building and driving tech initiatives and building for the next billion users. Public speaking, of course. That's why you're seeing me over here. So, with this, let's get started. And I would love to pose to you a rhetorical question. Like, is the end near? Is my question to you. I definitely don't want the end of the world, and definitely at all. So, this is just a rhetorical question. I would love to answer this while we are in this journey. You might say no, considering the rapid advancements in AI at this point. But I would like to take a step back and reflect upon what is happening with this advancement. So let's take a look at this next video. It's a pretty interesting one, and then towards the end of the session, we'll come back to this question again, and we'll try to answer throughout the session. I'm sure you all are excited. So let's see the video next.
Playing jazz.
Playing jazz.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, tandläkare at 9:30.
Fire off.
Fire off.
Open door.
Door open.
Så ska vi sätta en till.
Ah. Open door.
Run voice command.
Open door.
Run voice command.
Open door.
Repeat that.
Open door.
I didn't understand that.
Hey, open door.
Play on the floor.
Sing on the floor.
Get on the floor. Open the door.
Wrong voice command. Error.
Here, with a rock. Open door.
I'm sure it was quite funny, right? But isn't that scary too? Like, imagine a situation where we have a smart home completely enabled by a voice command, and but still we are not able to enter into our house or stuck within our house. Something happened. Uh, it's scary, right? So this brings us to the fundamental question: do we really understand AI? Do we understand the basic AI principle? Artificial intelligence has made rapid advancements in recent years, significantly improving the sophistication with which it can make decisions and automate tasks. We all know this. This has far reaching impacts on an individual's autonomy and considerably alters how societies functions. It has thus become imperative that we assess how AI is built and ensure that it is deployed in a manner that does not negatively impact individuals or societies. Here's an interesting quote from Garden's view on machine learning. It is true that they can follow instructions at superhuman speed with superhuman fidelity and over unimaginable quantities of data. We're talking about AI over here. But these instructions don't come from nowhere. Although neural networks might be said to write their own programs, they do so towards goals set by humans, us, using data collected for human purposes, for our own purposes. If the data is skewed, even by accident, the computers will amplify injustice. The keyword to note over here is amplifying injustice. Can computers or the AI based systems really amplify amplify injustice? I'm sure you would have seen this in the previous video. From an Indian context, the enterprises developing AI are making a considerable effort in adopting guidelines, frameworks, and other best practices. But they lag behind in conducting third party audits or impact assessments of their AI systems. In fact, boutique AI firms that provide niche AI products or services do better in most principles of responsible AI than big IT firms that provide AI as a service. So this talk will focus on 10 guidelines to assist all those that are involved in the design and development of AI-based systems. I'm sure by now you would have got an understanding that yes, we need to build a responsible AI system, and this is just from an Indian context, and but this is happening globally. Uh, Firms are not aware of how to build a responsible AI-based system. So this talk will talk about some of those guidelines that someone can take and design and develop their own AI-based systems, which is responsible, which makes sure that human is controlling everything, not the other way around. Let's start with some definitions. While AI is a catchy shorthand, the term comes with a lot of sci-fi baggage. You would have seen a lot of sci-fi movies, I'm sure. To sidestep this, some engineers now prefer the term machine intelligence rather than using artificial intelligence. But for layman purposes, they are basically the same thing. What they're trying to do is, what they're trying to say is that the science of making things smart is artificial intelligence or machine intelligence. Now, when we say smart, we don't necessarily mean they're generally intelligent or conscious in a way a person is. Instead, we simply mean that it is good at solving a particular problem or class of problems. Let's consider an analogy. Their planes fly, but they don't flap their wings. The aeroplanes, they fly, they don't flap their wings. And we don't pretend they are birds. It's the same with smart machines. They're smart related to the task at hand, but in their own way, in their own non-human way. We often use the terms machine learning and in AI interchangeably. That's because machine learning is a technique at the heart of our approaches to developing AI, but it's not the only possible approach. So, technically, machine learning is just a subset of AI, completely reliant on advances in machine learning. Now, as you can see from the picture over here, machine learning is a subset of artificial intelligence. Then deep learning is another subset of machine learning, which came into picture sometime in 1950s. Uh, Rather in the last decade, in 2010s. 1950s was the time when artificial intelligence came into picture. Then around 1970s, 1980s is when machine learning came into picture. And then in 2010, in the last decade, deep learning came into picture, which has led to a lot of deep learning breakthroughs in various industry verticals, not just restricted to IT verticals or information technology sector, but across the traditional services or sectors like consumer, your health, your finance, your retail, your government, your energy, your transportation, industrial, and other. These are some of the articles and use cases or application areas where deep learning has led to some of the breakthroughs that was not possible before. And of course, the last decade things have changed considerably. Uh, Things uh, have been in the better shape as compared to bigger data sets, faster computers, and our neural networks, of course. So momentum in creating better open source tools and dataset availability has also led to differences in the modern AI. For example, we know Python has become one of the main tools used in data science. A great advantage is that it is open source, yes, and has a large community of people working with it and expanding its library. So all in all, we can say that ML is helping improve consumer experience. I've just taken some of the applications which we use almost on a daily basis. These are applications developed by Google, like your search, your maps, your Chrome, your photos, your Android. All of them are enabled by machine learning and deep learning. So we can say, in a nutshell, yes, machine learning is helping us improve consumer experience. Okay. But let's understand what's the science behind these intelligent systems. What is powering them? It's a very basic structure to understand what is like how these intelligent systems are driven. But this will help us understand the next few guidelines or the guidelines that I'll be talking about in a better way. So we start off with data, with understanding like what is required for our business. So we start with the business understanding, what we need to achieve, what we need to do. Then based on the task that we need to do, the problem that we need to solve, we acquire data. We understand the data. When I say data acquisition understanding, we acquire data via maybe IoT devices or via human generated content, user generated content, as we say, or via other sources. So there's data sources, and then you understand the data, you try to explore the data further, you validate the data. That's what data acquisition understanding is all about. And then you try to model the data. You basically do feature engineering on the data, model training, which is a typical thing that we do in machine learning models, model evaluations, and everything, all those computations that you do. And then you try to deploy the data. You kind of build intelligent applications or integrate them with web services. Uh, this kind of an interconnected network of what is happening within an intelligent system, with business understanding, data acquisition on one side, then modeling on the other side, the deployment of the data. And it's kind of like a never-ending loop. The once you deploy it, you generate more data, then you try to understand the data, then you model it back, whether it's feasible for business interaction. So it's kind of like an interconnected loop. And ultimate end goal is to make sure that the customer accepts whatever you have built. They are familiar with the AI system that you are building, and yes, that's where the customer is happy. Customer is considering you as a brand that they can trust, they can rely on, and so on and so forth. So that's the science behind the intelligent systems. On how to build intelligent systems or systems, it's essentially like you generate more and more data that helps you build more and more accuracy. That's that. In turn, you are generating value out of the connected devices, your data sensors, your analytics, your data value, human value, communications, and so on and so forth, leading to a domino effect of smart things, which is essentially a correlation between how many AI systems one owns and one's willingness to get more. So when it comes to AI, the amount and type of information provided plays a key role in how people will perceive and whether they will embrace the intelligent systems. And that's what we can call this as the domino effect of smart things. Now, there are various ways to solve a particular problem or to build an intelligent AI based system, develop an intelligent AI based system. One of the problem solving approach that's highly recommended and kind of widely used in the industry these days is the design thinking approach, where you start with empathizing around a particular problem, you develop an understanding of the challenge, you clearly articulate the problem that you want to solve, followed by a brainstorming on possible solutions, potential solutions, and you select and develop which works best for the problem that you're solving, and then you design a prototype of it. You which you can test with the entire of it or the part of it which you can test with the end user, and then you actually test it out with the end user. You engage users over there. You can that will help you like continually improve your design. Now, why I'm touching base upon this design thinking approach is because this process helps in understanding the guidelines later on as well, like how you are understanding how you are understanding your problem statement better, what is it that you need to capture, ideation, prototype, and testing. So everything is kind of like relating to the guidelines that we'll be talking about in the next few slides. So let's touch base upon the guidelines directly. All right. So move on to the first guideline: ethical clarity and brand trust. So intelligent systems have been and will continue to be exposed to high scrutiny. Scrutiny will increase as mainstream awareness, standards, government mandates increases. And over here, trust plays a key role in the development of AI systems. Consumers usually go for a product if it is coming from a company they trusted, the company that keeps things private with no security breaches and scams. I'm sure you would agree with me on this, right? That you would go for a product which for a company which you trust a lot, which has a good brand reputation, where you can rely on your data and everything. So brand trust has the power to make or break someone's willingness to consider a smart system. Let's consider a situation. So uh, maybe you give out your data to an organization and there's a breach, data breach, the security breach with that organization. Definitely, your willingness to further engage with that company might go down. It doesn't matter on the product whether the product is really good. It all the way goes down to the company level. So that's when the brand trust can help you decide whether you would consider a smart system further or not, or any other future engagement with that brand. So that's the first guideline. Have a clear understanding of the data that you're capturing should be secure enough. It should follow the ethical practice. You should not like sell out the data of your consumers, of your customers to any third party. Let's look at the second guideline. In AI, we always say more the data, more the accuracy and efficiency. I also spoke about this earlier. But when designing and developing AI-based systems, we should use minimalism as a compass. Collect only the data that is necessary for you to successfully achieve the requested transaction. Do not collect anything and everything. Uh, Definitely, it would help you. It's a good to have. It's a good to have, fair enough, but you should not if it is not required for your actual model training and efficiency, then refrain. Collect as much less data as possible, only the data which is relevant for you to collect to actually train your model. So use minimalism as a compass, minimize the intrusion. Third guideline: prefer a relationship with intelligent systems where the system is in a subordinate role and that it attributes in machines that seems human like independent thinking, make people uncomfortable. So you should not make machines human, rather make them capable of helping humans. In other words, AI systems should build relationships with humans. They should always work in correlation. They should always ask before acting. Users should specify or authorize uh, whatever that needs to be done instead of the other way around. It should be humans taking control of the machines, rather machines taking control of humans. Make machines help humans. Let's look at the fourth guideline, which is designing helper usages. Usages without high ROI will have a long-term repercussions, impacting product success and users' willingness to embrace it. So design helper usages, like where they needs to go. Non-helper usages add value in the following areas, like your social connection, entertainment, and content augmentation. But design helper usages. Fifth, and really important, is serendipitous design. We always want intelligent systems to be consistent and predict our behaviors, but as humans, we always love serendipity. We don't want ourselves to be predicted like too often. Like you can't really, and you can't really predict also. So while being serendipitous, how you can make your systems intelligent? Human behavior, as I said, can't always be predicted. So, with this duality in mind, it is important to balance the contrasting perspective in your UX design. So, from a user's, from a developer's perspective or from a UX designer perspective, you need to be contextual, like build applications that are contextually aware, and they are adaptable systems. So these are the top 5 guidelines that I can say. Let's cover up the next 5 guidelines. So once you have identified the need or needs you want to address, you will want to assess whether ML can solve these needs in unique ways. There are plenty of legitimate problems that don't require an ML solution. So understand whether your whether your problem really needs an ML solution or not. That's the 6th guideline. The 7th guideline. Several like explain how machines think. Um, let's take an example. Self-driving cars provide another good example for AI and UX. So to build trust in passengers, we suggest putting a screen in the cars where everyone can check out what the car sees around itself. Now, as a human, you would know, okay, this is how the machine is thinking, and you can make corrective actions later on. And if you're not aware, like what is machine thinking, then you might not be able to understand like what needs to be done if something wrong happens. 8th guideline is differentiate AI content visually. So we suggest like if people know if an algorithm has generated a piece of content, uh, is it like something which they have generated, or is it like through the previous analysis or something? So the humans should know that whether the algorithm generates a piece of content, so they can decide for themselves whether to trust it or not. So there should be like a visual demarcation, like okay, this is an AI generated content, and this is like a usual content which is being kind of modified by AI, but not completely generated by AI. Find and handle weird edge cases. That's our guideline number 9. So AI can generate content and take actions no one had thought of before. So for such like unpredictable cases, we have to spend more time testing the products and finding weird, funny, and even disturbing or unpleasant edge cases. Oftentimes, as a developer, as a designer, we often overlook the edge cases. We don't consider those edge cases, but it's definitely required to build a responsible AI system. Let's understand our 10th guideline, our last guideline. Provide engineers with the right training data. So you really need training data. Uh, we have seen, like from my experience, I have seen that people saying that hey, we might not need training data, we can just like build systems on the go. UX people help collect training data and define the expected outcome people want to see from the AI product. So these guidelines are really crucial. So no, these are just the guidelines. I'm not saying that these are the rules. You can consider them as rules, but consider them as guidelines. These are like best practices, something that you should definitely do. And these are not just 10 of them, there are more of them. I just try to cover a bunch of them in a short span of time, just 10 over here. So what I'm trying to say is that adhering to these AI principles, such as like fairness, transparency, accountability, explainability, human control, etc., helps in better policy making at an enterprise and an industrial level. So to ensure that safe and responsible development of AI and is possible, and we avoid risk associated with the technology. That's the whole intent. Now, you must be wondering that I'm always talking about responsible AI, and you are on a daily basis using AI, and it's quite responsible. Um, even let's take an example of self-driving car like Waymo. It's quite responsible in itself. But I think the next video and a follow-up slide will help clear what I'm trying to say and convey over here in terms of responsible AI.
Open door.
Door open.
Radio on.
Playing radio.
And do lights.
Lights on.
Protein shake.
Making protein shake.
New York.
Loading New York. Set speed.
4.
4.
6.
6.
16.
16.
4.
Error.
Okay, 16. 4.
4.
16.
Correction. 16.
This is summer of '69.
69.
I think I skipped the Waymo video, but what I'm trying to say over here is uh, it's the responsibility lies on us of how we are building these systems, these AI based systems. So
Open door.
Door open.
coming back to the question again, is the end actually near? Well, it depends on us. It depends how we are building the system, how responsible the AI system is. The end might come if we don't build these systems responsibly. This might lead to fatal accidents in case of, let's say, self-driving cars, or in other ways, like AI system can control humans also. So we'll leave you with this question: is the end actually near? And we'll let you think about it, how to build an AI, responsible AI system. So that's it from my side. Thank you so much for joining in. That's where you can get connected. That's my Twitter handle at the rate Siddhant Agarwal 04 if you would like to get connected after the session. Thank you so much, everyone.